Point 1G, we review inequality symbols. And so here they are. And a big key thing to realize is these how the symbol looks, what it's telling you it means, or how it's read. And then we got those two examples. So that first symbol we read is less than. And remember, the small side of the inequality points towards the small number, or some people think of the crocodile eating the big number, whatever that number is, and however you remember it. But the next, this one right here includes when it is equal to a number. So that's less than or equal to. This is greater than and greater than or equal to. When we start to graph these things, keep in mind these, I'm going to highlight the other one that are just inequalities without the equality with them. When we graph these would be open circles on the number, and these would be closed circles to indicate they equal. And we'll see that here. So inequalities are just any expression that has, or any sentence that has an inequality, and then a constant or variables on both sides. Okay, so they don't have to have both on both sides, just one of them or both of them. And so these are all examples of linear, or rather, inequalities. Let's just decide that these things are true so we can see that, make sure we understand how to read an inequality. So this saying 3 is smaller or equal to 6. If 3 is less than or equal to 6, that is certainly true. Next one, -5 is greater than -2. Some people mess this one up. This is false, okay, even though the 5 is greater than 2, but -5 is not greater than -2. And if you ever have a doubt, just think about the number line. The further left you are, the smaller you are. So -2 is there, but -5 is way out here. There's -5 out there. So this would have to read -5 is less than -2. Okay, so this is going to be a false statement. The next one, 8 is greater than or equal to 8. Well, it has the equal part. 8 does equal 8, so that's true. And then our last one there, 9 is less than 9. No, 9 is not less than 9. It is equal to it, so that one is false. When we graph these inequalities in words, you can see numbers less than 3, and that's how we'd write it. So x is less than 3. And note the graph here. So I want x's, that's what I'm graphing, the values of x, and I want the ones that are less than 3. Now I put an open circle at 3 because it can't be equal to 3, just less than it. So at negative, or rather at 2.99999, that point is on this blue line here. And that blue line represents all the points that make this inequality true. Numbers less than or equal to 3, it's the same graph because there's all the numbers less than 3. But now we can fill in the dot because of the equality. Now let's look at the interval notation. Interval notation is a really fast way to indicate what the solutions are without the graph. And this just says, or it reads, the x is the values that start at, or go from 3 to -infinity. So they start at 3 and go to -infinity, which is to the left. Now notice it's a soft parenthesis right here. It's a soft parenthesis because this is an open circle at 3. And by putting the soft paren, it means don't include the 3. Now contrast that with the next one, or compare it. It's exactly the same, except now we use a hard bracket, and the hard bracket indicates we include the 3, the endpoint. We're never, incidentally, going to be using a hard bracket on an infinity. Infinities don't have an end, so you can't include an endpoint to it. It wouldn't make sense. So infinities always get these soft parentheses. Okay. Now we flipped it around. We want the numbers that are greater than 3. So x is greater than 3. Open circle at 3, and then to the right. And in fact, if you've recognized, when you have your x on the left-hand side, the inequality, notice this inequality points to the right, the direction your answers are will be to the right of that number. Up here, x is on the left and it points left, so the answers were to the left of the 3. And then our last one here, numbers greater than or equal to 3. So filled in circle at 3, everybody to the right. So we include the 3 now, but we're headed to positive infinity. Here we don't include the 3, so soft bracket. Here we do our parenthesis and then a hard bracket here to include that 3. So there it is, kind of summarizing the interval notation. Parentheses means don't include the endpoints. That's called exclusive. So we're not including. And the hard brackets mean do include the endpoints, and that shouldn't say exclusive. That should say inclusive. And one of your jobs today is going to be to, come up with all of these words in inequality interval notation in the graph for all of these inequalities. So in words, numbers greater than 4, inequality x is greater than 4, interval notation, soft paren. Then we're going from 4 to infinity. And we can see that when we draw the graph. And this is how you do your graphs on paper. So 4 is our point of interest, and you mark a 3 and a 5 to give everybody a sense of direction. We don't want to include the 4, so we just put an open circle at 4, and we got to go greater than it. That means go to the right, just like that. The next one, numbers greater than or equal to 4. So numbers greater than or equal to 4 are going to have exactly the same graph. And of course, greater than or equal to, it would be a filled in. And so you can see the notation we're using here. Numbers less than 3, there's our interval notation, and I think you understand the graphs, I hope now, but we'll find out when you do the homework. An example of a typical problem, write the inequality x is greater than negative 2 in interval notation. Okay, so here's interval notation. It's going to start at negative 2, and it's going to infinity to the right. Oops. Eraser, there you are. So we'll go to positive infinity, like so, and graph the values of x. So let's graph it. And you may want to graph it before you write interval notation. I think you may find that easier. So here's a negative 2, our point of interest. We'll make one number bigger than that and one number smaller than that. Open circle at 2, and we want to go to the right. We want things that are bigger than negative 2. So it looks like that. And so my interval notation is, well, I'm going from negative 2 to the right to positive infinity. So that's what I write, negative 2 to positive infinity. Parenthesis here because the circle is open. Inequality is x is less than or equal to 5. Let's take a look at that one. X is less than or equal to 5. I'm going to graph it first. My point of interest is 5. Makes this 4 and this 6. We want a filled in circle at 5 because we're less than or equal to it, and less than is in this direction. And now I can write my interval notation. It's going to be easier. I'm going from 5 right here to the left to negative infinity. So we put the smaller number on the left-hand side when we write it. So we're going to negative infinity, but we'll be starting at 5. And we're including the 5, but we never include the endpoint of negative or positive infinities. So there's our interval notation. All right, that should get you through assignment 1.1G.